Recording has started. Okay. Nobody sees it in the background, so I'm confused. But hey, everyone. Welcome to this fourth episode of CNCF Project Tours. Today we have Luca Guerra with us, who is going to talk about the Falco project. Luca works at Sysdig, a famous security company, the container security company. They do some pretty cool stuff, and their blog is full of some really awesome articles. I remember once reading something around dtrace. Um, so yeah, Luca is going to talk to us about Falco. He comes from Italy. I mean, he doesn't come from Italy. He has joined virtually from Italy, and he lives in the city Milan, which is also called as Milano. All right, Luca. So over to you. And if we'll have any questions, we'll not wait for you. We'll just ask you right away.
Of course. Well, thank you.
Over to you.
So today you came and asked something about Falco. So I have been working with Falco, with the Falco project, which is a CNCF graduated project, as you know, for 3 years now, more than 3 years. And we actually, with the team, with the maintainer team, with a fantastic maintainer team, we were able to get it to graduation status within the CNCF just last year. So first of all, I would like to ask, first of all, Dalmit, if you have ever heard about anything about the project and what is it that, why did you ask me to come and to talk about it? What is it that you're interested about? And then I'll tell you more about it.
Okay. For me personally, it was, I am not aware of Falco. I only know that it's something I should be using for security. I am a software developer. I mean, I work on Kubernetes and Go writing operators and stuff. So I was just curious to know how it might be useful for me. But what I do know is Shivlal was spending time spinning up a test environment yesterday and trying Falco out. And that's why he has some really interesting tidbits for you.
Of course. So Falco is useful for one of the several parts of security that you might need. So Falco is focused on runtime security. Runtime security means that in Falco's context, that Falco can identify every operation that is done by the system through analysis of system calls and sometimes more than system calls, and basically knows everything that happens. This means that you can be alerted about a lot of behaviors that your applications or whatever is installed in your cluster, in your hosts are doing by using a vast collection of rules. So it's a rule-based behavioral engine, which is based mostly on system calls, and also has an incredible and extensive plugin system that allows it to scan for events, to analyze behavior events, even in other sources. For example, you can connect it to your Kubernetes cluster with your Kubernetes audit events, if you've ever heard of them. So if you are not familiar with the difference, a system call is, for example, a file opening. This is a system call. But a Kubernetes audit event is something a bit different. Is, for example, when someone is logging into the cluster and is installing a new, is creating a new resource, is changing the security settings of the cluster itself. So it's interaction with the control plane of your Kubernetes cluster, for example. And Falco, with its plugins, can also read this activity. And not just those, it can also read activity from your AWS account, from your GitHub accounts, and from many other things, because we have really many plugins that you can choose from. And yeah, so you have mentioned trying to set Falco up, and maybe you wanted to know more about this.
But I have one question based on what
Yes.
you just said. This sounds like Falco is your cloud native S-trace.
Oh yeah, absolutely. Yeah. That's a very nice parallel, because S-trace is, if you're not familiar, is a tool that you would use to trace all the system calls that the program does. And what it does is normally you would run strace followed by the program that you want to run. And strace, the operation itself, would tell you exactly what happens. But strace does it for one process at a time, and also it's very slow because it uses ptrace, the system called ptrace, to do its job. It's like a debugger. It's like a lightweight debugger. Falco does this at scale for every process running on the system, and you will be able to set up rules to be alerted about everything that you are interested in. And not just that, because Falco will also tell you all the context about it. For example, strace would only tell you that this specific process didn't open, but Falco will tell you that this process that exists in this container, that exists in this cluster, that has these other bits of metadata is doing this operation. So it gives you a much richer context on a much larger scale.
Makes sense. And this sounds like the audit daemon that Linux systems come with. It contains so much information for every process that's running on the server or on the system. So now I get why you say that it's more of a auditing system rather than just tracking the system calls kind of thing.
Absolutely. It's Audit D is one of the inspirations, the original inspirations that made Falco what it is today. So it was one of the systems that that was used and is still used in some environment. Falco came in an era where containers and cloud were already very common and were already let's say being used by a lot of organizations, and so it came already with a functionality to analyze this kind of behavior in this kind of world that then became the cloud native world.
Makes sense. Thank you.
Of course.
I have a question, Luca. How does the idea of Falco come at the Sysdig? So,
so how
why?
did the project was born? How was
Yep.
where did so Sysdig, the company, has an had an application as a tool, created a tool at the beginning by our CTO and founder of the company I work at, who's called Loris. He had this idea about a system that could collect the system calls and could show the system call data for a variety of purposes. For example, it could work for application performance monitoring. So with system calls, you can have actually very interesting data about performance monitoring, or you could use it for troubleshooting, or you could use it for many other things. And there used to be, and there still is, a command line tool called Sysdig that that uses the same engine that Falco uses under the hood in order to just display a lot of data. Then, after I think a couple of years, the same people that worked on this software saw that it was very cool for auditing purposes. So they started using it for auditing purposes and for security, and it looked very effective. And this is why they created a new project based on the same idea, the same engine that is called Falco. The project itself, the software itself, under the hood uses a kernel module or eBPF probe, depending on the years, of course. Back at its inception, when the idea came out, the only way of doing this was with a kernel module. So that was the idea. And then in latest year, you've probably seen that we have eBPF, we have support for eBPF in the kernel that allows you to do exactly that, to hook into system calls, to hook into kernel functions, and to examine a kernel functionality with a lot of advantages compared to old style kernel modules. And this is why Falco today has a very actively maintained eBPF probe that works on the latest and greatest kernels that you can have in your environment.
So just like when I went to the Falco site, I can see that there are 3 supportive modules. Like so, let me just share the screen.
Yeah, of course.
So when I go to the docs, I can see that getting started. So deploy as a container, deploy, install on a host. There are multiple ways you can use Falcos, right? So
Yeah, of course. And actually, this is one of the most important characteristics of Falco. It's very compatible with a lot of environments. So you can. So Falco is compatible with kernel modules that I am not exactly sure which one is the earliest kernel module that currently works with Falco, but I think it might even be 2.6. Like some versions of 2.6 can work with Falco. You can install it. You can install it on up to the latest and greatest 6.6 kernel 6 versions. So you can install it. It works on x86-64 platforms. It works on ARM. It works even on architectures that you might not have heard about and on systems that you might not have heard about. So if we have support even for IBM Z. We have a maintainer that have run this on IBM Z. So, and it works on Kubernetes. It works as a container. It works in a container, and you can install it directly on your host. So it's we try to have it to make it so that it's easy, so that Falco is easy to install, regardless of your overall environment.
okay, all right. So do you have any underlying architecture how Falco works? If you can share.
Yeah, sure. Of course. So let's take a look at the. So I will show you on the website. Let's see if we have something that can show you very easily how this works. So. I can actually just go on Google and type in Falco architecture, and I will have a very nice diagram for me. There we go. So I will just can I share my screen? There we go. Just a second. There's so many articles that have been written about Falco, so you can find architectural diagram with a simple Google query without having to. So this diagram has been on the Falco website for a long time, and it's still there in some pages. And basically, this is the architecture that I have shown you, that I have described before. So we've got, we used to have only a kernel module, and today we have a choice of kernel module or eBPF probes, and these live in the kernel. What they do is that they collect all the system, all the data from your system calls, and we will output them to a series of libraries that perform a lot of enrichment, data enrichment. They will do whatever is needed to add context to your events, to the system call event. The good old strace event that we talked about before gets enriched, and this is enriched via container metadata, Kubernetes metadata, and many other things from the system itself. Then later, you have a rule engine, and I can show you exactly how this works, but that pretty much takes every event and will only output the ones that you're interested in. And the outputs for these events are whatever you want. So by default, back then, Falco would output events to a file, to standard output. But if we go to, for example, the output part of the channel part of the website, we can see that, yeah, you can do standard output or file or a program, but you also have gRPC, and you have another program called the Falco Sidekick that has automated output to about 60 different and possible, let's say this is the list, 60 different things that you can have to receive your Falco events. So you can output to Slack, you can output it to your SIEM, because we're talking about security audits here. So every possible SIEM is supported, the most popular ones, Security Lake, you have OTel traces, you have message queues, so Kafka, Nats, and you have many, many other things. And the cool part is that this is, of course, all open source, like everything else. And there's many people that come and add support for other systems because they use perhaps other things. And this is and also it has a little UI that shows you what's going on. On the flip side, if we can take a look here at plugins, we have a lot of information about one other part of the Falco architecture that is essentially, this is the developer guide, but probably we need a more high-level introduction. So we have a way for everyone to decide to create their own data sources. So we have talked about outputs, we've talked about where you can ship your events to, but where can you take them from? And there's no limit here, because we have created SDKs in Go, in C++, and now we have one in Rust that allow you to write whatever you want and have it as an input source for the plugins. You can find in our blog a lot of articles about how to monitor everything from. Some people have used it even to monitor Bitcoin prices, because why not? But maybe maybe other examples are your Okta log, for example, for an enterprise architect, for an enterprise system that uses Okta for authentication, or other events coming from the host, and many things that maybe are custom to your use case. So we can't know them in advance. So you have a lot of resources to write them. So the basic architecture is inputs from kernel module, BPF, and plugins, engine with rules, and an output that can be either simple standard output or many, many other things that you can plug in, of course, with our tools. Does that answer? Is that a bit clearer?
Yep, that's clear. So also, I can see the concepts here. Like if you want to focus on this concepts also, like event sources, rules, and outputs.
Of course. So we have rules. Let's take a look at examples of these rules. So currently in Falco, you can simply, if you download Falco, it will come, and we'll take a look at that. It will come with some rules that are already loaded into it. Of course, everything is open source, and the cool part is that everything is customizable. So, Shivla, let's take a look. These rules are created in such a way that they should be very simple to read and easy to read and easy to write. So, for instance, I have this rule over here. If just a rule is composed by a description, of course, a condition, and an output, which is the string that will be displayed to the user. If you read this rule, I am pretty sure that you will be able to understand completely what it does. If you take a look at the rule I have on screen, maybe I can zoom it a little bit. You can really take a look, and it should be very simple to understand. So we got an open read and sensitive files, and we have with a process name, and the process name is not in a series of processes that we know we are not interested for the rule. So and for a bunch of these. Sometimes there are conditions that look like open read. These are macros because it's like a function. So we can take a look here. And the rule is very easy to understand. This is a basic condition with Falco. So it will just say that the event type is three system calls: open, open-ended, and 2, which are 3 system calls that are used to open a file. And there is a flag that tells you if the event is for open read, and there is a type character that says it's a file, and we have a file descriptor number that's greater than 0, and everyone that has used that has programmed on Linux or Unix-like systems knows what why we're interested in file descriptor numbers that are greater than 0. And that's really it. That's all about it. You could write your own rule. We've got supported events. You can choose from hundreds of events. These are all the system calls that Falco supports. Falco only supports a subset of the entire system calls that Linux has, but we add support for more at every version, and every time we will write it here, so you will see exactly what Falco can have. And for each event, all these rules that I've showed you, can use hundreds of fields that are all the context that I was describing. So for instance, you are interested in the executable name of the process. I think this is something very basic. I think you might be interested in the process name, of course, but maybe in the process parent, in the command line that's used to run the process, and many, many, many other things, everything that you can, users, containers, even for the file descriptors, there's statistics on the file descriptor, and all these things that all systems engineers that work with Linux-based systems know and want to know. So this is how a rule looks like, and how a rule is written, and how you find more information. Of course, on the website, we have guides for everything here. So you can write your own rules, and here in the documentation, everything is explained about how can you write rules, where you find examples, and all the things. There's about 85 rules or repositories that I showed you there, and it's linked from the website, Falco Security/rules. And you can be just inspired by those, use those, and even customize them to your own needs.
So, right. No. So am I audible?
Yeah.
Yeah. So I have got one question. Like, you have mentioned that the Falco is run on Kubernetes environment and containers. So like Falco, we can run Falco on like non-Kubernetes environment.
Yeah, of course. You can run Falco on your host. Just think of a Linux system. Just even a Linux system that runs on a bare metal system, it just works. You can run it inside the container. So perhaps you have containers, you have whatever container support, but it's not Kubernetes. Maybe it's just containers, or it's something else, and you can run it there as well. And yeah, wherever you might like.
Okay. So yeah, that's it.
So if you want to install it on your host, you can either use the packages that you install with the apt-get or RPM. So for this kind of distributions, or we have created tarballs that contain statically linked binary. At least we try to have them as compatible and as widely compatible as possible. And we both have statically linked and dynamically linked binaries. The dynamic one try to be as compatible as possible with Linux, and also there's a lightweight version that doesn't have all the features enabled, but is a fully statically linked binary that runs pretty much everywhere in every system that you can think of.
So on the local, it can also it can detect the threat like real time. So when we are running on local, not on the Kubernetes environment.
Absolutely. It detects in real time. And if you want to try it on your own host, okay, it's very easy. You go to the website, you click on Try Falco, and we have three options here for you, just to go over the simple setup. The Ubuntu one uses a VM just to have a common environment. you can install it on your environment. You can actually set it up by deb. If you have a deb-based system, you can just click here. Or Docker is, I think using Docker is a nice idea because you don't have to do any modification to your system. You just run a command and Falco will start, and here it will, the guide will walk you through how you can see a rule that is installed, how you can create your own rule, and how you can actually see it in action in real time.
Okay. Yeah.
So, well, I think it might be time to actually show you what it's like. I described how to install this, and now I can actually go and show what I'm talking about.
I think Dharmit had one question. Dharmit,
Yeah.
you have?
Not really a question, mate, but maybe something like wanted to confirm my understanding that Falco runs as an eBPF probe. Earlier, it probably worked as a kernel module, as you said, but now that you have eBPF, everything is, of course, eBPF. Because when you started out, said that it's like audit the asterisk, I was like, oh boy, the system load this one's going to cause is going to be insane. But then it's an eBPF probe, so that's out of the picture. What I'm really curious about is its installation on Kubernetes, because you don't usually get so many privileges. If you're running as a Docker container, I saw it was a minus privileged flag, right? This thing is going to require a lot of privileges, and that itself is one of the security concern I have. Security concern for a security tool. I don't know if that makes sense.
Okay, I could talk about this for hours, so I'll try to be brief. So that's really a great question. Like, damn it. I think as a maintainer myself, I'm also worried about this. So first of all, we're talking here about a system that is able to read every system call that happens everywhere. This means that by definition, the system needs to be super privileged, because that's how it works. Because imagine if something that was not super privileged had the right to see everything that happens somewhere else. It would be a security problem in the operating system itself. And of course, we are. And of course, Falco does require a lot of privileges. But there have been efforts to reduce the amount of capabilities that the Falco process itself has, so that you don't have to use that -- privilege flag. As a maintainer, and especially as a security person, not even a Falco maintainer, I would assume that Falco itself, like every security tool that you might use, has its own security, let's say, its own security impact, because that's how the world works, and this is valid for every tool that you might install. So, and also as a maintainer, what can I do about this? So what we did is we tried to be as diligent as possible about the security of the Falco project itself. So, Falco is written in a variety of languages. The core is C and C++. We have plugins in Go, and we have plugins in Rust, and these other things. So we have security audits on our code base. We have implemented static checks on everything that goes in, of course, for all the C++ best practice that allow us to have a greater level of security. And we also have dynamic analysis that runs on our own code when we do testing, when we submit PRs, and all these things, with the security checking built into the analysis. So we are trying to do our best, and fortunately, in the last security audit that we had prior to CNCF graduation, they had some great suggestions for us, but fortunately, there was nothing glaring in the architecture and the security of code, which put us a bit more at ease. But we always have to be very vigilant and very focused on security. And there's not a lot more than you can do than investing resources in trying to be more secure, because I think there's no way that a security tool is not somehow security sensitive itself. It's of course the adoption of eBPF helps us with that, because the kernel module a kernel module can crash the kernel much more easily than an eBPF probe can. So we are trying to use eBPF, leverage eBPF as much as possible so that our code has a much lower chance of doing anything bad, any of our bugs, because we're humans and write bugs, sadly. Any of our bugs will have a much lesser chance to impact your system. And this is what we do. That's my opinion on the subject.
Makes sense. Thank you so much for answering that.
All right. So let's just take a quick look about what we can do with Falco, and answer any questions that you might have afterwards. So I think you can see. My screen. So here I have a Kubernetes cluster, and I have one pod here. It's a simple Nginx. It's like a hello world for Nginx, because I just wanted to simulate something that you might have running in the cluster. And I just wanted to show you how easy it is to install Falco in your cluster. So I showed you a guide that was that was how to run Falco with Kubernetes, and the guide will tell you to run this command line. We are using a Helm chart as it's standard, and it says simply to install Falco, and also we are enabling this project called Falco Sidekick. I've already mentioned it. It does two things. One is sending your events, your Falco events, to wherever you want, and the other is also setting up a little UI. So we'll have a web user interface available for us to just visualize our rules better. Normally, in a complex system, you would use whatever monitoring system you have. But in this case, we will use the Falco Sidekick UI that will really help us visualize all that we have seen and we have talked about until now. So let's take a look at the pods, and we can see that Falco has some pods that are running. What it's doing right now is setting everything up for us. We've got a UI that's running. We've got a bunch of Falco pods that are starting up. It's configuring this. It's doing everything under the hood. It's detecting our cluster type, and it's running Falco for us. Okay, all looks good. So we can log in, and we can also have a nice little UI that I can show you so that we can take a look. I will probably, since I can only share one. Let's see if I can share this entire screen. Sorry. Let's see. Share screen. I can share. No, I think I can share a window at a time, but that's not a problem. So let's log into this window, and it's localhost 2802. And we have an interface that has a default password. Don't use the default password in case you're installing. And I have something that is happening in my cluster. So let's first of all, let's take a look at events. And this is something that I think I did on the cluster before. Yeah, I did them before, but since 24 hours, let's take a look at what happened since 12 hours. Nothing has happened since 12 hours. So let's make something happen then. Let's make something happen. We are back in our cluster. We're back here. And let's do something bad. So first, we have this nice little pod that is running. First, we can take a look also to the Falco output just to see that it's running properly. And of course, this is loaded correctly. All is good. So let's try to do something bad. Let's imagine that someone, maybe someone bad, logged into this pod. So we're going to do an exec here. And what is something bad that we can think about? Honestly, if I got a shell, if I'm an attacker and I got a shell somewhere, I would do maybe two things. One would be trying to extract any secret information that the thing might, the container that I'm in might have. And the other might be to deploy whatever is my malware of choice that can get persistence in my target cluster. So let's try to deploy something. Of course, I'm not uploading any malware here, but for instance, I could download BusyBox. That's a simple command line application. And I can run it. So let's imagine this is, of course, this is not a malware, but an attacker might have run a malware or a script, and then might have gone to etc shadow. It's just a file that lists the users, and the attacker could be interested in that. So now let's head back to Falco and let's take a look at what happened in our Falco setup. So window. There we go. So it's telling me that there's a bunch of events that have happened. So let's take a look in specifically what happened. And I can see 4 events here. The first one is terminal shelling container. So it says that at 2:40 and 47, since the cluster is set up as UTC time, so it's 2:40 right now in the afternoon, and a shell was spawned in a container. So it's telling me a lot of things about it. It's telling me about the executable path that was bash, the parent of the container, which is container diffshim because it's container parent, the command, and the container ID, of course. Also, we are running Kubernetes, so we know that this container was launched by an image that was Nginx image, and we know that it was in the default namespace in Kubernetes and in a specific pod name. So we know many things about this. So let's take a look at the other events. What happened then? There was a drop and execute binary in container. So you remember when I downloaded BusyBox? Falco has noticed that I have run an application that wasn't in the container original image. So normally container images are immutable, but this time something else was injected in that. I know that some containers do it. There's nothing that stops you from doing that. But in many real-world cases, you won't ever do it. So me going there and downloading BusyBox and running it was something suspicious that Falco by default detects as suspicious. So let's take a look. Of course, the pod name is the same. The executable is the same. Then I have more information about how long the process how long the cluster was there since it started, and many other things that you can take a look at in the manual. And so that's very interesting. And then afterwards, we can take a look at how the other events. You ran cat on etc shadow 2 times, and so I have 2 separate events. And these ones will show just what happened in this specific environment. So this is simply a cat to etc shadow, and someone has run this program, and this is suspicious. And this is really the core of what Falco does. And of course, since here we can actually take a look at the rules themselves that have created this operation. We have a rules explorer, and this rule is called is the one that I showed you. But maybe we can show drop binary in a container. Let's take a look at it. We have our rule, and this is how the rule is defined. You can take a look. You can take a closer look, and it's shipped by default. You can customize the rules if you want. I'm going to stop here for a second, so I will be asking if you have any questions about what you just saw, or if you are thinking about a use case that you would like to implement with Falco, and maybe I can explain. Sorry, I didn't get the question.
We are seeing here on the dashboard, like process ID, the command that run. So how this directly like went through from syscall to this dashboard?
So this is a great question, and this is how the Falco architecture works. So as I think I showed before, the general idea is that we had one. Here is an eBPF probe. Actually, this image is a bit dated. We have an eBPF probe that sent the event to these two libraries, libsysp and libscap, that are contained in the that are, let's say, core to what Falco does. When the event is received, these libraries will enrich it with all the other metadata. This metadata is collected by observing. Falco does it automatically, of course, by observing several things. And in your case, I think there's three things that are in play here. First, how the processes look like on the system, because you only have a one system call, but on the system there's a whole tree of processes. So you have to know the parent of the process, and many other things around basically the content of the proc file system. If you have ever used the Linux system with these low-level details, these things are automatically collected by Falco as it goes. And they are also collected by the other system calls that happen. So first, you can see an exec v of a process. So it knows which process it is, linked to a specific process ID. And then it sees an operation. And then it knows what the operation is and uses the metadata to enrich context. And then there's two more sources. One comes from the container engine. So my cluster runs containerd. So Falco in the background continuously queries and checks and integrates with the containerd to take a look at which containers are enabled and links every process to its own container. This is done currently, especially in the next version. We'll have an even more powerful version of this container integration with more integrations with many that supports many more different type of container engines. And then there's Kubernetes, because there is this thing called Falco Kubernetes Meta Collector. And let's say if I have a diagram for this, we have a plugin. There's a lot of explanation, but I don't think I have a diagram ready for this, that essentially connects to the Kubernetes APIs and is very efficient in getting all the data that is what you are running in the cluster. So it continuously monitors what happens and, of course, performs linking between the processes and the Kubernetes namespace and the Kubernetes pod name and all this other information. And so at the end of the day, you get everything in the dashboard without having to worry about it.
Right, right.
Cool.
And,
yeah.
One more question regarding the setup. So, do we need to set up the Falco sidekick differently, or it is just included in the Helm chart?
Oh yeah, the setup that I did, I can show it again to you, because I really want you for you to be clear. Let me take a look on the screen. There we go. Yeah, this line does everything. This single line also installs Falco Sidekick with the UI. The UI is great for me to show you the power of Falco, but you probably want to maybe you don't want to use the web UI of Falco Sidekick itself, or maybe you want to use your own forwarding events to SIEM. And for this, there is extensive documentation in the Falco Sidekick website about how to set up your own output, because maybe you have another log aggregator. But for this is the only line that you need. And that did everything that I showed you without... As you can see, it just said it's deployed, and then the pods just just started. It's Falco has detected my type of cluster and installed the appropriate binary and everything.
We have one question from Mahesh. He's saying, "Hi Luca, Falco seems to be great at detecting security events and alerting. Is threat prevention also included?"
So Falco, thanks for the question. Of course, Falco does not do out-of-the-box threat prevention, but there's several community projects that do threat response. So you can take a look at, for example, a project from last year from the community that's called Falco Talon, that is in development. And actually, I heard from the maintainer that they're looking for community people that help with the development, that help shape up its development. I can take it. Let's take it to the. Let's show you the repo. Let's share it again. Let's show the repo. We have this here. That is a very new project and in need for maintainers and for people from the community that want to contribute to its development. And it is Kubernetes native, so it does operations and actions on your Kubernetes cluster. And yeah, you can take a look at it. We have blog posts about it. You can take a look at what it does. You can contact the current maintainers, and the best thing you can do is getting involved in the development because this is very promising for us. It is a very promising thing that we have seen the community create for Falco. But remember, Falco cannot do prevention. So it is designed never to block an operation specifically. That's true. That was a design choice for Falco because it's more used for auditing purposes.
Right. People, I think we don't have much questions in. If feel free to add your questions in the Q&A. Q&A is there. Like many of the beginners who want to contribute to, like I'm as a CNCF ambassador, I want to contribute to I want to get involved to CNCF projects like Falco and other security projects of CNCF landscape. So how can I start as a first-time contributor for the Falco for any project? Like let's take an example of Falco already.
Of course. So for Falco itself, there's so many ways you can contribute, and I can think about some contributors, some maintainers that came and did great contributions, and they all follow different paths. So there is I don't think we have in Falco one avenue to come, but it really depends on you. So let me give you a few ideas. Let me give you a few ideas with and share. I will share again. So this is the main Falco repository, but it's not the only one. So depend on what you want to do. So are you interested in something like a low-level kernel? So eBPF, kernel modules, and fighting with very tiny details of how fundamentally your system works. You probably want to. I think you probably are interested in one of a couple things. But we've got our Falco libraries repository that is where the magic happens at the core. So this is something. These are libraries that you can use both in Falco and in other systems. There's people that use in other systems, but these are libraries that interact with the very core of the operating system itself. So this is something where you could be interested if you are an engineer that wants to write programs there. If you are a Falco user, on the other hand, so you have used Falco, you like the functionality, but you would like something more out of it, Probably depends on your background. Maybe you are not well versed into very low-level coding. You might want to either contribute to the main Falco project, or if this looks maybe very time-consuming and you would like something with an easier feedback loop, you can work on plugins. So maybe you want Falco to get a new data source for you. You have a cluster. Some people came with specific types of clusters or cloud accounts that they wanted to monitor with Falco, but they couldn't because we didn't have support. They came, they wrote plugins, and they contributed them to the community. And now we have them along with all the other plugins that exist. So this is a great way of contributing. Or maybe you are more well-versed into writing. So we have a documentation website, and we try to keep it updated. But of course, Falco has a small team. Some issues can be there. So take a look at the website. If you think there will be something that could benefit from your skills, we are very more than welcome to get them. We are talking about Falco Sidekick and Falco Talon. These ones are written in Go. So maybe you don't like C++, but you want to add more features to the outputs of Falco and what happens around Falco, and those are the projects for you. So I think there's a lot of ways to contribute to this project. For example, my favorite would be writing a plugin at this point. I like low level and ePPF and this kind of things. But maybe I didn't write a lot of ePPF. So I want, instead of adding my own code to the main Falco, I can write my own plugin that does my own thing and enriches the data that Falco gets. And this is nice. You can see it immediately. And then you can come to us, and we'll be super happy that you showed us your work. These are just a few ways. If you have any questions, we've got the Falco, falco.org/community. We've got Slack channel on the Kubernetes Slack, Twitter, LinkedIn, and GitHub for issues and conversations, and you can come to us, maintainers, for any questions, or if you want to contribute and don't know where to start, and if you are looking for recommendations for this kind of for contributing to Falco.
And is Falco included in any of the open source programs like GSOC or Outreachy or LFX?
Sorry, which? Oh yeah, sure. Yeah, GSOC, for example. Yeah, we ran GSOC twice, I think. We ran GSOC twice with students. They had a great experience. Honestly, I did not handle that specific part, so I don't know what will happen in the future. But we had some great experience with GSOC, and if we have maintainer time, we would like to continue with that.
All right. I think we don't have much questions from my side. Team, if you have any questions, Tamit, Sanket.
Nope, nothing from me. I'm just completely in awe right now about what it does. And I was also looking at other tools in the space like NeoVector and Tetragon, I think, if I'm not saying it incorrectly. This seems like a really cool space to keep an eye on.
Yeah, of course. You can find many tools that are similar, and they all will be focused on different things. You have mentioned Tetragon, for example, and I think that tool is focused more on the blocking side, for instance. So the Tetragon rules compared the Tetragon policies compared to Falco do slightly different things, and they give you power to look at very specific kernel events that are harder to use, but they can perform blocking. And in my opinion, for example, my personal opinion, are great to examine surgically examine some parts of your environment, but they are not as comprehensive as Falco rules. So but that's my opinion. So I think everyone would just try a bunch of different ones, and depending on their needs and their goals and what they want to achieve with them, they will find the right solution for them. We hope Falco is useful for as many people as possible, and because we think many people will enjoy the level of context and compatibility that Falco provides. But it's a cool space to be in for many people, for everyone.
Yep, I was yesterday doing a setup on my local EKS cluster, like playing with syscalls, how it handles through all the way through syscalls. So I found it really interesting. I think there is just the last question from Mahesh. What suggestions do you have for cluster administrators interested in deploying Falco?
What solutions for deploying Falco?
What suggestions do you have for what suggestions do you have for cluster administrators?
So suggestions. You want to deploy Falco? I would say start. First of all, of course, start small and take a look at how it works. The guides, the getting started guides that you can find here, are very simple and straightforward, and you can start by deploying this in a test cluster that you might have. If you like what you see, your biggest challenge after you deploy it, you start rolling out the deployment to the target clusters that you want, will be configuring your rules. This is going to be probably the big challenge that you have, because
hello there, I'm Sankar Gayakar. I'm a cloud engineer. I'll be joining ASAC 2.2.
Sorry.
Sorry, it was from Sanket. Sorry.
Okay. Anyways, you will probably want to know how you can tune and configure the rules, and we have guides for that. Of course, we have additional resources here. You have you will probably want to deep down into how the rules works and how you can. You will have two challenges. One is reducing the noise. We have created the default rules to be as lean as possible, but we don't know what your environment. So you will probably have some rule that you might want to disable, tune out, to remove, and to do this kind of things. And on the other side, you will want to learn from your users what is it that they want to be alerted about, that you want to be alerted about as an administrator or your security team. So take your time to learn what your needs are with the organization where you're deploying Falco, and take a bit of time to write a rule or something that will do exactly what you want. At that point, you will have your own personal Falco that will do exactly what you want, and you will know how it works. So the journey to have a large-scale installation of Falco is not just one Helm command. The Helm command helps, but then I would really encourage you to learn a little bit more about how you can customize your own rules.
Thanks.
Luca, one last quick question. If I wanted to monitor some system call which is not covered in Falco right now, that's something that has to go at the best level, right?
Monitoring a system call that is not currently supported by Falco needs to be required support inside Falco itself. So you can both ask, of course, we have a list somewhere of system calls that we don't support. You can ask, especially if it's security relevant, we'll try our best to implement it. Or you can contribute.
Always welcome. Yep.
Yeah, you can contribute it if you want to write. If you want to write some low-level code and if you feel adventurous, you can contribute it. Or in some cases, if you want something very specific for you, there's also a plugin route. I know that it's possible to create some plugins that collect some kind of events that Falco does not support yet, without having to wait for Falco to support it. And that's but Falco requires explicit support for every new system call or event.
Okay, got that. That was very helpful.
I think we are out of questions. And thanks, Luca, for joining us and sharing your the knowledge and experience on Falco. And I hope you enjoyed this podcast. You enjoyed this session with us.
Absolutely, that was great. Thank you so much for having me. And of course, you can find us, all of us, for the Falco team in the Kubernetes Slack, in the Falco channel. We're there. We try to answer questions as best as we can. It's a small team, but we always welcome people that are interested. So thank you so much for this. I really enjoyed it.
Yeah. Thanks for joining.
Thank you, Luca.
Thank you.